thank you W.Media for this opportunity to allow me to moderate this esteemed panel really. You've already done the introduction, so I'll skip there in the interest of time. So, AI, has ushered a new era of, computing density, right? So what happens is, AI computing is 10 times more than what a normal computing is. So which means kind of, while we are having these AI operating models, kind of being operational, what it means is more power. What it is being said is globally, the requirement of data center power is set to double by 2030. Yeah, that's right. And 50% of this extra power which we are talking is all coming from AI. So, which means that, this workload, is having several impacts, right? So, maybe the surge is kind of, in my view, a triple challenge. The first challenge is there is an impact on business, which means your costs are rising and the energy costs are rising. The second thing really is from the operational impact, right? So there is a limit to the infrastructure, so there is a strain on it, obviously, and then there is a capacity limitation, so that's the second one. And then there is environmental impact, so much of power, it is causing harm to your carbon footprint. Basically, we are increasing carbon footprint. So what I would kind of summarize is that every megawatt saved is every megawatt generated today. And that is the kind of the topic we have today, is reducing power wastage in this AI advent of what we are having. So, with me are three of industry's best minds who can kind of debate, and one is a supplier, one is a developer of data center, and one is a technical consultant. So, it's a very varied panel and we can get different views. So maybe then I'll start with you, Mr. Mori. Yes. And you are the HVAC man, which consumes, 50-60% of this total power which comes in AI, right? Yes. So what role, AI and the digital twins, which is what kind of you are now introducing and using, play in improving, the overall efficiency of power? We are talking about the reduction of power, how do we save power? How would HVAC function, help in all that?
Okay, thank you so much for the question. Very nice question for us. We are dedicated for the HVAC operations by the control skills. Okay, and we basically do the controls by the controllers. This is in premise, and over top we need to utilize the AI and etc. The nowadays technology, high-cap technologies. Okay, mostly any vendors use to judge the deteriorations and the performance is good for each equipment. Chiller unit, pump, and etc. is good performance or not. And mainly the Azbil side, using about the energy saving, not only that, we try to find the optimum point of the operations. You can image about the conventional chiller plant. For example, chiller unit will make the capacity of the cooling, and the pump will send the water to the AHU side, right? And each equipment will aim for the same target. The set point is quite same. The chiller unit every time output the 7 degree, and the pump every time try to output the same pressures. But each one have the relation of the pros and cons like it. So some is up, some is down. So which point is the optimum? A little bit difficult to find by the humans. But the digital twin and the machine learning can find very easily any optimum point. So we utilize to find the optimum point for each. Not only this case, but any kind of the case, we can find the optimum point with the AI and the machine learning. This is the point from the Azbil. I like it.
But it also helps in so one is in the installation, the other is on the operations. How does digital twin then help in having efficiencies in operations? How can it reduce power?
Okay, noted. Yeah, sometimes some point is deteriorated. So that even the same concept of the chiller unit and the AHUs, but the performance is different. So every time catch up by any data records. But this data record analysis is a little bit difficult. But the AI and the machine learning technology can do very easily. Human is a little bit difficult about this part, right? So we can utilize about this one for the energy saving, for the HVAC control and the HVAC equipment.
Maybe I'll come to you, Ganesh. Then you are as Equinix. You are a big data center operator in India. Do you think with this advent of AI-heavy GPUs, is PUE still the metrics, or do you think something else is now to be considered besides the traditional PUE which we used to talk a few years back?
Yeah, I think of course PUE has its own significance and it is going to remain as it is because it measures the overall efficiency or performance of the data center, and it is also playing an important role of financial metrics wherein customers are billed basis on the PUE. So basis on these two reasons, PUE is going to stay forever for sure. In addition to PUE, it has limitations because of since AI consumes humongous amount of power in the data center, it does not capture the actual work done by the IT equipment. So that is a limitation of PUE, wherein we see there are new metrics which are coming in the market and which are gaining a lot of significance as far as measuring the workload done by the IT equipment, especially for every single kilowatt which is being used in the data center. So that's where we got energy to compute ratio, which is being introduced in the data center to measure the overall performance of the IT equipment. The second new metrics which is coming in the data center is about carbon per inference or carbon usage effectiveness, wherein CO2 emission for the entire energy used for the whole data center and divided by the IT power, which gives the carbon usage effectiveness or carbon per inference. Now, the ideal value of carbon usage effectiveness has to be 0 if someone has to go for 100% carbon neutral or 100% renewable energy for the entire energy which is being used in the data center. I would like to tell you about Equinix. We had a commitment of going carbon neutral by 2030. As on today, our energy coverage across globe is 96%. So our carbon usage effectiveness is quite healthy and quite good across the global data centers. The last is energy reuse. So whatever IT consumption done by the AI workloads, how much energy is being reused? So I would like to tell you about, we almost export 14.5 gigawatt of heat, and then it is exported to nearby industries for various applications. So in a recent Paris Olympics, our Paris data center exported the heat and we warmed the swimming pools there. So that is how the application has been done. So these are the new matrices which are getting a lot of significance as far as measuring the performance at the IT server level or AI server level, in addition to the PUE, which measures the overall infrastructure efficiency.
Thank you very much, and that's really very commendable. That the swimming pool is being heated from extra heat, which is coming from a data center. That's really something to be cherished of. Mr. Khan, I'll come to you then, and maybe talk a little bit about the grid side. So we talk about this smart grid interface, right? So and then there are data centers where we are dynamically kind of balancing the renewable input. So which means it is a combination of the power which is normally produced as well as the renewable power. How do we combine that, and how do we kind of address the peak load demand and spikes in it? Maybe you can give some reference of the grid and then talk a little bit about that.
Yeah, sure about it. See, today the AI has changed how the data is being processed. Not only that, it has rewritten the physics of power consumption. See, as Mr. Ameya pointed out in the start of the discussion, that power demand by AI is going to be doubled by 2030. In today's metrics, today the global data center consumes around 53 gigawatts of power, which is expected to rise up to 65 gigawatts by next year and double to 130 gigawatts by 2030. That's the power consumption we are looking at. So, in the past, the data centers were following the grid where the power availability was there, but today the grid is following the data center. So that is the thing, and we are witnessing a shift in the industry, which is the great power shift, where the energy has become the true currency of intelligence. having said about the smart grids, absolutely, because AI has completely changed how the data center is consuming the current power. See, in the GPU clusters, where the AI, what we say the AI and the GPU clusters, the power demand is not steady state or a constant flow. It has its own spikes and dips. When the workloads ramps up in the GPUs, they start consuming more power, and when the workload gets shifted, the power goes down. But your renewables on the grid follows the sun and the wind. So when the sun rises, you get more power, and when sun goes down in the evening, you tend to get lesser power from the solar system, unless otherwise you have a battery energy storage system. So this is the imbalance which is causing to the grid. So how to maximize and how to smartly use the power consumption from the grid. So we have this open ADR protocols which is now available, and with the open access policies introduced by Government of India, and now most of the state governments are also allowing open access across India, barring few states. I think Maharashtra is being a pioneer in that, and UP has started already. So with this open ADR technologies, the live signals can be sent out from a data center and from the grid. It starts communicating with each other. So where my GPU loads are getting up, so based on that, what is my availability of the renewable power or the power availability in the grid, I can start manipulating it and using AI. See, we think that AI is guzzling power, but AI is the only solution to stop guzzling power as well. So with the help of the AI, with proper training of the models and other things, we can easily manage the workloads on the GPUs. Again, the GPU power consumption is based on various factors of your training models and various stages it is happening. And using all these things, we can intelligently cover up the smart. We can easily implement the smart grid into it. And now, see, in the age of AI, what is the new byte? What is the new byte? And those who master energy will master intelligence.
Absolutely. Thank you very much for that. Maybe Mr. Mori, you talk about the HVAC earlier, so while AI is causing a lot of power to get consumed, how do we, use AI to kind of optimize things, optimize solutions, optimize operations? I mean, from an HVAC standpoint, are there any AI tools which are being used, which are helping in optimizing power?
Yes, thank you so much. Nowadays, AI data center making the one big topics. Refrigerant will change from the air cool to the liquid. So that this type, maybe AI data center mixed the design of the liquid and the air cool both maybe, and this one making increment of the variable of the HVACs. Which is better to use in some situations, liquid type or air-cooled type like it. So we can judge which percentage for the capacity, 40 and 60 or 20 or 80 like it. This one also can use for the optimum point of finding by the AIs. This is also very good chance for the AI about the AI data center era. I think so.
Yeah. Okay. Thank you. So Ganesh, do you want to add to it?
I just would like to add to the answer about this question. I think digital twin is definitely going to help in a long run as far as AI is concerned. And where we are failing in a traditional air conditioning system is we are not able to monitor the chillers efficiency in a real time, or even the IKW in a real time. So AI is going to help, and then the algorithm is going to help to have the real-time monitoring of the IKW and the maximum chiller efficiency, because the maximum chiller efficiency gets between 40 to 70% of the chiller load. So that's where we are expecting AI to help and give us those real-time metrics where our whether the chillers are operating in optimal efficiency level or not operating in the efficiency level. In fact, in addition to that, if chiller is not operating at the efficiency level, AI is further doing and adding the guidance and direction that go and check these steps, and because of these steps, the efficiency has been dropped.
Maybe, just time is up. So the final comment is, reducing power wastage. Maybe Ganesh, I'll start with you. What are the emerging things, a couple of technologies which are coming, and how can we reduce, wastage of power? Maybe this is the last thing, one minute each, and then we will hand it back to you.
Yeah, so in a traditional system, we are using all AC and we have multiple conversions. So getting the transformers for step down, step up, the UPS having double convergence. So wherever in entire AC distribution and transmission, we are having humongous amount of losses, which is hidden cost in the data center. So these days, all the data center designers are bringing all these utilities next to your data hall. That's where the overall distance between the utilities to the equipment has been reduced, and then higher efficiency products have already come, be it UPS or be it the transformer or be it eco mode of the UPS. But if you really wipe out the overall conversion losses which AC has, then the ideal solution is of course to go on DC. If you get 800, 400 volt DC, then convert it to 48 volt, give it to directly to the equipments, because equipments are anyway consuming only DC, and then we are converting all AC to DC at multiple places before it actually going to the IT racks.
Thank you. So you are saying DC could be one of the solutions upcoming.
Yeah, adding to it, as we are, as everybody is intending to use AI to monitor your power loads and power consumption, how to reduce it. So it is not about the smarter algorithm, it's about the smarter accountability. See, nowadays a powered or a GPU cluster can draw power in gigawatts, and it can be the power which is consumed by a small country to itself. So with this, what we intend to do is, we need to bring in a lot of accountability and transparency in transparency and government policy framework, so that how the power is consumed smarter and how efficiently it has been used to process the compute power, and how the electrons can be utilized intelligently. So there is what
intelligence and accountability
will play a big role.
Sure. I know, we are this is a fascinating topic and a lot can be said about it, but time is short, so we need to hand it over back to
last point, having said that, though our technology is advancing very fast, leaping very fast, but our policies and energy codes are still lagging decades behind, so which we need to work on together as an industry.
Well, with this note, I will thank all the esteemed panel for your views, and thank you for the opportunity, and thank you audience for listening. Thank you very much.
Thank you so much.